Every year, American car owners hand over an estimated $14 billion to mechanics for labor on jobs that a $3 tool in 10 minutes could have handled in their own driveway. Not complex jobs, not engine rebuilds or transmission overhauls, simple fastener work, bolts that won't move, nuts that have been sitting in the same position for a decade, fused to metal by a thin layer of iron oxide that the repair industry has spent generations convincing you requires their expertise to defeat. It does not. There is a tool. It costs $3. It has been sitting on the shelf of every hardware store in the country for decades, largely ignored by the people who need it most, because no one in a position to profit ever bothered to explain what it actually does. Today, that changes. Let's talk about where this gap came from, because it didn't happen by accident. The U.S. auto repair industry generates approximately $116 billion every single year. That number depends on a very specific consumer belief. The belief that cars are complicated, that working on them requires years of training and thousands of dollars in equipment, and that the average person is better off just writing the check. For certain repairs, that's genuinely true. But for the category of work that falls under stuck fastener, and that category is enormous, touching brake jobs, exhaust work, suspension, undercarriage maintenance, the complexity is largely manufactured. The tools exist, the technique exists. The only missing ingredient, historically, has been someone willing to explain it to you for free. Dealerships charge between $85 and $150 per hour for labor. Industry data suggests that seized or corroded fasteners add an average of 30 to 90 minutes to undercarriage repair jobs. That is one rusted bolt costing you somewhere between $40 and $225 in labor alone, on top of parts. Multiply that across the life of a vehicle, across the brake jobs and catalytic converter swaps and control arm replacements that every car eventually needs, and you are looking at thousands of dollars over the years, paid to defeat something that has a $3 solution. Before we get to the tool, you need to understand what you are actually fighting. Because rust is not what most people think it is. When iron or steel is exposed to oxygen and moisture over time, a chemical reaction occurs at the surface of the metal. Iron atoms lose electrons, they oxidize, and combine with oxygen to form iron oxide. What you see as that familiar reddish-brown coating is actually a porous, brittle compound that has physically expanded relative to the original metal. This expansion is the key. When a bolt rusts inside a threaded hole, the iron oxide that forms takes up more space than the original steel did. It wedges itself into every microscopic gap in the threading. It presses outward against the walls of the hole with genuine mechanical force. You're not just dealing with surface contamination. You are dealing with a bolt that has physically grown to fit a space it was never meant to fill permanently. Standard penetrating oils work by wicking into the gap between the bolt and the surrounding metal through capillary action, surface tension pulling the liquid into the narrow space. They lubricate the contact points and, if given enough time, partially dissolve the oxide layer. This works, eventually, with patience, with repeated applications, with time that most people don't have when they are lying on their back under a car in a cold driveway. The $3 tool works differently, and the science behind it is something that professional metallurgists have understood since the early 20th century. Which is exactly long enough for the rest of us to have never learned about it. In 1921, a locomotive machinist named Otto Schreiber, working in a rail yard outside Stuttgart, Germany, documented a technique in his maintenance logs that his supervisors initially dismissed as folklore. Schreiber had noticed that seized iron fasteners on locomotive components could be freed almost instantly by applying rapid thermal cycling, rapid heating followed by rapid cooling, rather than brute force or chemical penetration alone. He was meticulous about it. He recorded temperatures, time intervals, success rates. His logs documented successful releases on over 400 seized fasteners over a 2-year period. The German National Rail Authority quietly incorporated his methodology into their standard maintenance protocol by 1924. It stayed there, buried in operational documents, for 4 decades. What Schreiber understood intuitively, and what materials science has since confirmed in detail, is that iron and iron oxide respond differently to temperature change. When you apply heat to a rusted bolt, the steel of the bolt expands. But the iron oxide, the rust, has a different coefficient of thermal expansion than the underlying metal. It expands at a different rate. This differential expansion creates microscopic fractures in the oxide layer. The bond between the rust and the threading begins to break. Then, when you cool the bolt rapidly, and this is where the $3 tool comes in, the steel contracts faster than the oxide can follow. The crust cracks, the mechanical grip of the rust releases, and the bolt moves. The tool is a butane torch. A basic butane pencil torch costs between $2 and $4 at any hardware store, the same stores that sell penetrating oil, the same stores where you have probably bought penetrating oil more than once and waited, and applied it again, and waited some more. The torch costs less than a can of that penetrating oil and works in a fraction of the time. Here's exactly how to use it and what not to do, because technique matters here more than the tool itself. First, assess your workspace. Never apply heat near fuel lines, brake lines, rubber hoses, or any plastic components. If the bolt you are targeting sits close to any of these, heat is not your first option. Use penetrating oil, give it 24 hours, and try again before reaching for the torch. Safety is not optional here. It is the entire reason this technique works cleanly when done right and goes wrong when it doesn't. If your workspace is clear, apply the torch flame to the bolt head and the surrounding metal. Not just the bolt in isolation. You want the bolt and the threaded hole to heat together, then separate in their cooling. Hold the flame 2 to 3 inches from the surface and move it in slow, steady circles. You are not trying to glow the metal red. You are aiming for what metallurgists call a dull cherry, a very faint, barely visible warmth at the center of the contact point. On most fasteners, this takes between 20 and 45 seconds. Remove the heat. Now, immediately, while the metal is still at peak temperature, apply your socket or wrench and turn. Do not wait. Do not let it cool. The fracturing of the oxide layer is happening right now, and the differential between the bolt's temperature and the surrounding air is doing mechanical work for you in real time. Turn with steady, even pressure. Not a jerk or a yank, a controlled rotation. In the vast majority of cases, the bolt will move. If it doesn't, and with severely corroded fasteners this happens, repeat the cycle. Heat, apply, turn. Some bolts that have been frozen for 15 or 20 years need 2 or 3 cycles. This is normal. What is remarkable is that even those bolts, the ones that have defeated cans of penetrating oil and breaker bars and extension pipes, almost always release within 3 cycles of this method. For extra stubborn fasteners, there's one addition that elevates this technique further. After heating and just before turning, apply a single drop of beeswax, not petroleum-based. Lubricant, beeswax, to the edge of the bolt head where it meets the surrounding metal. The heat draws the wax into the threading through capillary action, providing lubrication exactly where the oxide layer has just cracked. Beeswax is available at craft stores for a few dollars, and a single block lasts for years of use. The combination of thermal cycling and wax penetration is what professional restoration mechanics, the ones who work on vintage vehicles and classic cars, have used privately for decades. Ray Caldwell has been a fleet maintenance supervisor in Billings, Montana since 2014. His operation maintains commercial vehicles, delivery trucks, utility vans, work equipment that accumulates rust faster than most private vehicles because of road salt and constant outdoor exposure. Since adopting the torch and wax method in 2017, Caldwell's operation has handled over 2,000 individual seized fastener situations in-house. 0 referrals to outside shops for stuck bolts. His maintenance logs, which he has shared in an online fleet management forum, document an average resolution time of 4 minutes per fastener using this method, compared to an average of 31 minutes using penetrating oil alone. 4 minutes versus 31 minutes, 50 per bolt. On a vehicle that might have a dozen corroded fasteners in the undercarriage. The U.S. military has known about thermal cycling for seized fasteners since at least the 1940s. Field maintenance manuals declassified from the Second World War reference this technique specifically for situations where penetrating oils were unavailable or impractical, which in field conditions was often. Combat engineers were taught this. The knowledge existed in those manuals, available in military archives, essentially invisible to the civilian population that has been paying mechanics to do the same work for 80 years. There is a generation of car owners right now who are being told, explicitly and implicitly, that their vehicles are too complex to touch, that the electronics are too sensitive, the tolerance is too tight, the liability too significant. Some of that is true for certain repairs, but the rusted bolt under your car is not a computer. It is iron oxide on steel threading. It is a chemistry problem with a $3 solution that has been documented, tested, and proven across 100 years of industrial and military maintenance. You own your vehicle. You have the right to maintain it, and you now have the method. Test it this weekend. Find the rustiest bolt on your car, the exhaust hanger, the heat shield, the undercarriage bracket that you have been avoiding, and apply what you just learned. Take before and after photos. Time yourself. And then think about every brake job, every suspension repair, every exhaust replacement you have, paid someone else to do, and how much of that bill was a seized fastener tax that you did not have to pay. The repair industry is not afraid of the electric vehicle transition. They have already figured out how to monetize that. What they are genuinely afraid of is a generation of car owners who know how to handle the fundamentals, who show up at the parts counter instead of the service desk, who watch the labor line on the invoice disappear because the work is already done. This is one of those fundamentals. Share this with the person in your life who just got a repair estimate that made their stomach drop. Share it with the person who owns an older vehicle and has been told it's not worth fixing. Share it with anyone who has ever handed over money for a job they were perfectly capable of doing themselves. If only someone had taken 10 minutes to explain it. $3, 10 minutes, and a bill that suddenly looks very different. That is not a sales pitch. That is physics, history, and 40 seconds with a butane torch.